Betelgeuse could explode at any moment, or maybe it already did. And if that's the case, we're not just witnessing a cool space event. We're looking at something that could shake the foundations of everything we thought we understood about how stars live and die, how galaxies evolve, and where Earth fits into the cosmic equation. A calm sky could suddenly erupt with a second sun, a flash so bright it outshines everything else, even in daylight, and stays for weeks. But then what? How far would the shockwaves of a supernova like this ripple? Could we really be standing this close to something we've only seen in simulations? Betelgeuse isn't just another star. It's a ticking time bomb, a heavyweight on its final breath. And its death might not just mark the end of an era, but the beginning of a whole new chapter in our understanding of the universe. This isn't just a flash in the sky. It's a front row seat to how the universe rewrites itself. Betelgeuse is a red supergiant hanging out in the Orion constellation, about 640 light-years from Earth. It's not just big, it's absurdly massive. One of the largest and brightest stars visible to the naked eye. If you dropped it into our solar system, it would swallow Mercury, Venus, Earth, Mars, and keep going past Jupiter like it's nothing. And here's the crazy part. It's only about 10 million years old. That's nothing in cosmic terms, a baby. But somehow, it's already burning out. Massive stars like Betelgeuse live fast and die hard. With a mass 15 to 20 times greater than our Sun, it's been tearing through its fuel like there's no tomorrow. Think of a jet engine locked at full throttle, unstoppable but doomed to break. That's why scientists are obsessed with it. We're not just looking at a star, we're watching the final act of a cosmic monster live. But here's the kicker, Betelgeuse is close. Not wipe us out close, but watch it from your backyard close. That's rare. Supernovae this nearby almost never happen in human timescales. That's why telescopes are locked in. That's why we're all watching. Because what if the show already started and the light's just now arriving? Stars like Betelgeuse don't go out quietly. When it starts running low on fuel, the chaos begins. The core begins fusing heavier and heavier elements like carbon, oxygen, silicon, until it hits iron. And here's the deal. Fusing iron doesn't release energy. It sucks it up. The star can't hold itself up anymore, and gravity doesn't forgive weakness. As the iron core builds, there's no more outward pressure to fight against gravity. The whole thing collapses in on itself in seconds. A gravitational freefall on a cosmic scale. That's the point of no return. What happens next? That depends on the star's mass. If it's around 15 times the mass of our Sun, the collapse halts the core, becomes a super dense neutron star. The outer layers slam into it and bounce off in a massive explosion, a supernova. The kind of explosion that lights up the universe. But if the mass is higher, closer to 20 or 25 solar masses, the collapse doesn't stop. The pressure becomes so extreme that even neutrons get crushed. And at that point, the star doesn't explode. It disappears. No light, no flash, just gone. A black hole born in silence. The wild part? We still don't know which fate awaits Betelgeuse. We don't know its exact mass, or its exact distance. And with stars like this, tiny differences change everything. The spin, the structure, even its metallic makeup. One variable flips the outcome. When Betelgeuse finally explodes, it'll be visible even under blue skies. Its brightness could rival the full moon. Some models say it might outshine it entirely. At night, it'll drown out every other star in the sky, including Sirius, and hang up there for weeks, maybe months. And this won't be reflected light like the moon. This will be raw, burning power from deep inside a collapsing star. For context, our Sun puts out about 3.8 times 10 a quarter watts. A supernova like Betelgeuse could hit 10 alcubot. That's 500 billion suns all going off at once. This is energy on a scale we can barely comprehend. And here's the kicker. It's happening close enough to see it in wild detail, but far enough to not get scorched. Scientists say that only stars within about 100 light-years could actually harm us. Betelgeuse, it's nearly 6 times farther. So Earth? Safe. No radiation storms, no extinction-level threat. At worst, a little extra glow in the atmosphere. Maybe some strange auroras. That's it. But the galaxy? That's another story. A supernova isn't just an explosion, it's a reset switch. The death of a star like Betelgeuse throws out elements heavier than iron, gold, uranium, platinum, the raw materials for building the future. The blast wave tears across space, smashing into gas and dust clouds. Sometimes it disrupts them. Other times, it compresses them and gives birth to new stars. One death triggers dozens of beginnings. So when Betelgeuse goes, it won't just mark the end of one star, it'll kick off a chain reaction, a wave of creation that echoes through the galaxy. That's not destruction. That's cosmic renewal. And we might get to watch it happen. When Betelgeuse finally goes, it won't just be a show for stargazers. It'll be a once-in-history opportunity for science to watch a star die, up close and in real time. Astronomers are already on alert. The second that flash hits the sky, telescopes around the world on mountaintops, in deserts, in orbit, will lock on. Including the James Webb Space Telescope, ready to catch every detail across the spectrum from radio to gamma rays. But this isn't just about pretty visuals. We'll detect neutrinos, near massless particles that escape the core seconds before the explosion becomes visible. Think of them as the star's final whisper reaching us just ahead of the blast. And if Betelgeuse produces gravitational waves, observatories like LIGO will pick up the ripple, a literal shiver in space-time. We'll be able to test what, until now, has only lived in textbooks. How matter behaves at the breaking point, how elements are scattered through space, what actually happens when a black hole is born. For the first time ever, we won't just theorize about a supernova. We'll study one before, during, and after with precision we never had before. This isn't just rare. This is the kind of event that redefines what science can do. We don't know exactly when it will happen. Maybe thousands of years from now. Or maybe right now. Maybe the light from the explosion is already racing toward us through space. And if that's true, we'll be the first to see it. Whatever happens, one thing is certain. The moment Betelgeuse lights up our sky won't just be an event. It'll be a turning point. We'll witness a new understanding of the universe being born, and we'll be ready for it. What do you think? Could Betelgeuse really become the first supernova we ever witness in real time? Or are we in for a silent collapse, a black hole with no warning at all? Drop your thoughts in the comments. Let's talk about it together. And if you want to keep exploring how science is reshaping the way we see the cosmos, don't forget to subscribe to Lori Space. We don't just talk about stars. We talk about the very nature of the universe.